friends. Today we are going to start a new concept in aptitude classes, which is nothing but time and distance. Time and distance. Friends, time and distance is very important because if you if the examiner if the the person who is making the question paper, if you want to make the exam tough, means he'll put the tough questions on this only, because it is somewhat difficult. It's a lengthy topic. It is combination of time and work, averages, percentages. This is time and distance is overall combine of three concepts: time and work, averages, percentages. Don't worry, I'll discuss that also, because if I start this now, you can understand that very easily. Initially I should start that first because it's very easy. I no need to put more effort on it, because averages, percentages, those will not be asked in any examination. It's just a basic for this. So what I suggest you to follow this time and distance. Friends, let me assume that, let me tell this. See friends, always distance traveled depends on two factors. Depends on two factors. What are those factors? Speed and time. Speed and time. So what is the relation between speed, time and distance? So distance is equal to speed into time. Distance is equal to speed into time. Distance is equal to speed into time. Suppose, let me assume that I'm going on a bike with 40 kilometers per hour. What it describes that for first 1 hour I'll finish 40 kilometers, and second hour I'll go 40 kilometers, and third hour I'll go 40 kilometers. So distance is equal to speed into time. Now what is speed? 40 kilometers per hour now. So 40 into 3, which means d is equal to 120 kilometers. So distance is equal to 120 kilometers. So what I can tell you, that speed is equal to distance by time. Time is equal to distance by speed, right or not? So always, if distance is in kilometers, time should be in hours, and speed should be in kilometer per hour. If distance is in meters na, time should be in seconds, and speed should be in minute per second. 1 kilometer per hour is equal to, how can I convert in meter per second? You know, no, 5 by 18 into meter per second. Why? How will get this one? Let me detail. 1 kilometer per hour is, so for 1 hour we are having how many seconds? 3600 seconds na. So 1 kilometer means 1000 meters na. So 1000 into meter per second, which is nothing but this will get cancelled. So 10 by 36, which is nothing but 5 by 18. So 1 kilometer per hour is equal to 5 by 18 meter per second. So 1 hour is equal to 60 minutes. So 1 minute is equal to 1 by 60 hours. Right or no, friends? Friends, did you get this introduction? Now friends, we'll be having three relations which are very important. Basics. This is very basics. These three relations are basics of time and distance. Friends, time and distance will take time. Don't worry, I'll finish it within a short span of time. Let me assume that what is relation number one. What is relation number one? So distance is equal to speed into time now. If I put time constant, time is constant. If time is constant, what is the relation between d and s? Distance is directly proportional to s now. Means if distance increases, speed should increase. If distance decreases, speed should decrease. Right or no, friends? So speed kilometer per hour, time hours, distance kilometers. Distance is nothing but speed into time now. Let me assume that I'm going 10 kilometers per hour. Time is constant, 4 hours. What is distance? Speed into time now. So 10 into 40 kilometers. Let me assume that I'm going with 40 kilometers per hour. Time is constant, 4 hours. What is now? 160 kilometers now. Distance is equal to. Let me assume that I'm going for 20 kilometers per hour. Time is constant, within that much 80 kilometers. Now see, 10 into 4 is nothing but 40 now. So 40 into 4. 40 divided by 2 is 20 na. So 60 divided by 2 is 80 kilometers. Because distance and speed is directly proportional. If time is constant, distance and speed is directly proportional na. So this is the relation 1. What is the relation 1? If time is constant, speed and distance are directly proportional. Let me go through relation 2. Relation 2. Somewhat problem with this one. Just wait friends, sorry. So let me go through relation 2. What is relation 2? If speed is constant, if speed is constant, relation 2, speed is constant, distance is equal to speed into time. If speed is maintained constant, then what is relation d and t? Directly proportional na. Let me change the d kilometers. D is kilometers. Speed is constant. Let me change that 40 kilometers per hour. 40 kilometers per hour. What is time? Let me assume the distance is 80. I'm going 40 kilometers per hour na. So for 80 kilometers it will take me 2 hours na, right or not? Let me assume the distance is 40 kilometers, so it take me 1 hour na. Let me assume that is 160 kilometers, so per hour I'm going, time is 4 hours na, because for 1 hour I'm going 40 kilometers. So 40 divided by 2 is 20 na, therefore 2 divided by 2. 80 into 2 160 na, therefore 2 into 2 4 hours. Friends, did you understand? Friends, if not understand, please put it in comment box. Definitely I'll go through this. Now let me go through relation 3. Same manner here, distance maintained constant. So distance is equal to speed into time. If distance is maintained constant, what is relation with speed and time? It is inversely proportional. Speed and time are inversely proportional if distance is constant. Let me assume that speed is kilometers per hour, distance is 40 kilometers constant. Now time in hours. Let me assume that I'm going 40 kilometers per hour. 40 kilometers hour. Time is equal to distance. Time is equal to distance and speed. Now what is time now? 1 hour now. Let me assume that I'm doing 10 kilometers per hour. 10 kilometers per hour. What is that now? 4 hours now. Right or not? Let me assume that I'm 20 kilometers per hour, which is nothing but 2 hours now. Here 40 divided by 4 now means you'll got 1 into 4 now. Here 40 divided by 2, which is nothing but 1 into 2, because inversely proportional. If it comes here division, definitely it will get multiplication, because inversely proportional. If distance decrease, if speed decreases, then automatically time will increase, because inversely proportional. If time increases, speed decreases. If time decreases, speed increases. In the case of distance is constant. These are the 3 relations, friends, which is very important. These 3 relations are the basics of time and distance. So this is the introduction to time and distance. We'll go through the problems and relative speed, problems on trains. We'll go through this, friends. Thank you. You just follow this lecture video. This is the introduction. With this, I'll end up the session. We'll be discussing the problems in the coming lecture videos. Thank you, friends.